All right, let's see, pushing forward. Let's see if this setup can survive a little bit longer. So this is going to be the continuation of that chapter 4 to 7 review sheet that I sent out. We got through 4A1 earlier, so I'm going to go 4A part 2. It says, what's the probability that x is between 274 and 292? So if I look at this, I know it's normal from earlier. I know the mean is 281.2. And I'm curious about the probability. I don't want to move the table too much. All right. Oh, jeebus. That is from 274 to 292. By now, hopefully, this is starting to be very familiar. If I find this area, I can subtract this area, but before I can find the areas, I need to find the z-score so I can look them up. So the z-score for 274, let's see, standard deviation is 34.48. And if I do this, 274 minus, not 2 minus, 281.2 divided by 34.48. Bam, I get negative 0.21. And if I do it for, let me just do it in here. I can just hit second enter, go back, change this to what I want it to be, which is 292 for the second one, 0.31. So if I look up 0.31, I'll get too much area, 0.31, 0.6217. So 0.6217 minus, now if I look up negative 0.21, I get 0.4168. All right, this looks tricky. 2, oh shit. Let's see, 0, 4, 9. How's that sound? 61620 6217. Yes. Woohoo! All right. So that's 4A part 2. All right. So you can pause it there. I'm about to erase magically. Yeah. All right. So then the third one says it's probably x is less than 100. That's pretty far away from the mean. The mean is 281.2. I want to know that probably x is less than 100. If I'd hazard a guess, it's going to be probably close to 0. Let's see. So if I calculate a z-score for this, 100 minus 281.2 divided by 34.48. What do you think it's going to be, Jeff? About 5.6. Sure, why not? Let's see what it is. 100 minus 281.2 divided by 34.48. I don't even remember what I said. 5.6, I was off. 5.26. All right, just forgot the 2. And of course, that's off the chart. If you look it up on the chart, that's where it's going to say 0.0001. I prefer about 0%. So I would accept either one of these answers. All right. Part B is interesting. So for part B, we need to remember what we got for 4A1, which of course I forget. Yay, Jeff. So give me a minute. Okay, so I believe, so here's why it's related to 4A1, because it asks us how many would have a score greater than 302. And I knew there's a total of 2,000 students. And so if I knew the percentage that got greater than 302, I could just take the percentage of 2,000. But from recall, in 4A1, we did calculate the percentage of more than 302. And if I remember correctly, I think it was a z-score of 0.6, which is 0.7257. Why does that sound off? Well, shit. Hopefully that is what I got. So that's almost 73%. So if I do 72.57% of 2,000, I will get, what do you get, Jeff? 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. I get 14, 5. Why don't you just do it here, dude? 0.7257 times 2,000. 1451.4. All right. Coolness. So, I mean, it's a number of people. How many would we expect to have it? So I would say about 1,451, I would expect. Okay. Part C of number 4 says, what is the lowest score that replaces a student in the top 5%? So here's the top 5%. So that means there's 95% down there, which means now I can find that z-score, 0.95. Is that weird one, remember, with the asterisk? So that's going to be 1.645. What's the lowest score that could place? So then I need this backwards. I know the z-score. I need to know what the raw score is. So x equals the mean plus z times sigma, which was, what was it, 34.48? So if I do that, 281.2 plus 1.645 times 34.48, I get 337.9196. So roughly 338. All right, and then now part D should be the part that you knew was coming. I pick a sample of 33 students, and the question is about the sample mean, which means the very first thing I need to do is to change the standard deviation. So let me do that here, and then I'll probably wipe the slate clean so we could do this. So it used to be 34.48. Now I have to divide that by the square root of 33 to see what the spread is for groups of 33. So what do you think that's going to be, Jeff? It's going to be roughly 6. I don't know. It's going to be right around 6. 34.48 divided by the square root of 33. Holy shit. All right. 6.002. All right. So let me do some magic. You guys can stop it if you want. All right. So picking up where I left off there. We got the new standard deviation for groups of 33. So now I can answer questions about sample means from groups of 33 because I know how spread out groups of 33 are. So again, the picture is definitely still normal. It's even more normal, sort of. Not really, but I will. So the mean stays the same, which was, Jeff, 281.2. Yes, 281.2. Greater than 302 is what I'm curious about. So let me make a z-score. This seems just like the very first problem we did, except I'm going to divide by the appropriate spread, which is 6.002. 02, Jeff? Yes. It's going to be roughly 3 1/3, I think 3.33. Let's see. 302 minus 281.2 divided by 6.002. All right, sure. 3.47. That's almost off the chart. Look up 3.47. I'm going to get 9997. So then the right answer is going to be 1 minus that, which is 0.0003. Woo! Very small chance that a group of 33 would be that far above the mean, which makes sense. Okay, a little more magic. Now I want the probability for 42. I want the probability that it's between 274, the sample mean is, and 292. So I got to make both of these into z-scores. Let me see, the blue pen I think is a little bit better for my crappy writing. Just to cut to the chase, all right, so a little bit of magic. The z-scores for those two values, negative 1.2 and 1.8. So if I look up 1.8, I get 0.9641. That, of course, is going to be this much. And if I look up negative 1.2, I get 0.1151. That, of course, is going to be this much. So if I subtract those two, I'll just end up with the amount that's in there. And then when I subtract them, I get 0.849. 9549. Yeah, 9. Yeah, okay. Well, that's 9. So just double checking. All right, so that's 4D2. Okay. Let me see. I'm at 10 minutes. Let's try to finish this out. Let's see how this works.